Hey, you're about to embark on a pretty long video. I hope it's instructive. If you're new to JavaScript, using the JavaScript tools, want to learn how to design a two-player game and use a debugger and see me make a lot of mistakes, but then find them and correct them. Hope you can join me and watch this. Stuff you're going to learn. Like I said, we're going to edit JavaScript using VS Code, and we're going to debug in the Chrome DevTools. Control-Shift-J will open up the DevTools panel. You can see your source code, you can set breakpoints, you can type in JavaScript to try out things, and we'll show that. I'm also talking about how to design a two-person game algorithm using the Minimax search. We also start off writing unit tests really early. I talk about the philosophy of test-driven development, and something that I use a lot in my when I was working professionally. And you'll see me struggling a little bit with debugging. There's kind of a long sequence of going through and having some stupid mistakes I made, but then eventually found them. But you'll see how I solved those, and then eventually we get to the point where we have working Tic-Tac-Toe AI using Minimax. There's no, I ran out of, I think this video is already long enough. I'm going to add in a future video, I'll add user interface to it so you can actually interactively play against the computer. But for now, we just have a bunch of tests that shows that it works as much as they do. So anyway, enjoy, and I hope you have fun. All right, let's write a tic-tac-toe game. And I think the first thing we should do is just figure out how we're going to represent a tic-tac-toe board. So we're going to have 9 different squares, and each of these we're going to have to put different symbols in here for X's and O's. So let's create an array of 9. We'll just do an array of 9 elements, and we can say an X is going to equal to a number 1, an O is going to be equal to a -1, and then nothing at all will be a 0. And then we'll use those values in our array. So this board up here, we have the indices of an array. So this is, I'm sorry. These are the different indexes of our array. So we could have a board. This one up here is going to be first a -1 because there's a 0 in that upper left position. I mean an O in the upper left position, then a 1, and then nothing. And then the next one would be nothing, an X, and nothing, and the bottom one would be nothing and an O and nothing. So that would be the definition of our board. All right, so let's try writing some code. Okay, bring up Visual Studio Code. Let's just write a very simple, the most simple kind of web page that we're going to put some JavaScript in and just debug it all in Chrome. And but we'll write our code in Visual Studio. So first thing we need to do is create index.htm. This is going to be just the most simple HTML page, so we can get our code into here. And we're going to include a, let's put our script not in this page, but just in a separate JavaScript file. So it's source, it's going to be, let's see, tic-tac-toe.js, and that is it. And then body tag in here, and we're just going to write, let's do a big title that just says tic-tac-toe. Okay, now we can view that. let's see, open with live server. See how that works. Yeah, there we go. So now we have a, here's a Chrome page that's updated. I have this extension called live server. And I think if you just type in here, and let's see, do I have to save it? I'm not even sure if it auto saves, but let's see if I save it. Boom! It just updates the web page. Yeah, I can just go back and show you what I was doing there. So in Visual Studio Code, I can say Tic-Tac-Toe changed, save this out, and then as soon as I go back, or changes, it's already on there. I could refresh this page, but you don't actually have to do that. So anyway, going back to this code here, I'll take that out. So we just want, this is just going to be a very basic. We're going to do a lot of stuff in the debugging tools of Chrome instead of like in the web page itself, just to start out and get our JavaScript code written. So we have Tic-Tac-Toe.js. All right. So one function I think we're going to need is just to determine whether one side has won the game or not. I think in designing this code, we want to write a function that will find the best possible move for a given board. But let's write a few kind of little helper functions, and we'll get some testing running first. So actually, let's write a function that will tell us if a board is completely full. So first of all, we said if our board is going to be an array of up to 9 things. So if we have a function is full, and it's going to take a board, and it's going to return true or false. And so we'd say we're gonna loop this position variable. We just write a very simple for loop, and if the board at that position is say not equal 0, that means, oh, actually, that's right. If at any time we find an empty square in this board, we know that the oops, sorry. We know that the board is not full, so we can just return false. And if we go through all of these board positions and everything has some non-zero value in it, then the board is full. Okay, so I'm going to save that out, and if I load this into this Tic-Tac-Toe, of course you can't see anything because there's some script in here. I'm going to hit Control-Shift-J, and that is going to bring up. Ooh. Here we go. Here's our code. There's our. Oh, okay, interesting. If we look at this live server thing I'm using is actually injecting some code here, but this is our actual code, and I could do something in the browser now. Let's see. Let's make sure my font is big enough to see. There we go. How's that? So let's say our board, and we're just going to put an empty board. So that is a board that has nothing in it. And I just type out board, and that's what I see. And we have some other functions in here in JavaScript, like console.log of board, and that's just going to print out what the board is too. So you can see it has 9 empty elements in it. If I type is full, it says that there's my function. So what if I type is full of board, call that function, it says false. That's good. Now let's try creating one that has 9 ones in it. There we go. Is full of board. True. Great. So now we have a function that does that. But rather than kind of test things manually like this, another way to do this is to write some tests right in our code. Now I'm just going to put all the tests in the same file. Normally I would create a separate JavaScript file, but just for simplicity I'm just going to put it all together, and we'll write some test functions at the top of this. So going back to Visual Studio Code, let's say I'm going to write a function that says test is full. That's all this function is going to do. And for our purposes, we're just going to console.log the success of this function or not. Okay, I get a side view here. Going back to our test is full function. So we're going to write a function which will just run some tests. And if it fails any test, we're going to use a function called console.assert to assert that certain things are true about our code. So for example, if I do console.assert and I say false, and then I'll say that is never true. That happens to be the test that I'm running here. If I save that out, and then if I go over here and run this function, test is full. There it says I got an assertion failed, is never true, and you can click in the Chrome DevTools here. You can see where the code is on line 11. You can click on that, and you can see where that code is failing. So very handy. Okay, but we need some actual tests. So let's go through and test our isFull function. And let's say is full, and if we pass it, say a totally empty array. That. Let's see, and then we're going to call the isFull function on that, and so that should be returning. We're going to say that should be returning false, right? And we'll just say that's the empty board, is that particular test. Okay, so that's our first test. Let's going to run that. We come over here and say test is full, and we run that function. Nothing happens because the console dot assert was passed the value true for the first parameter, and so it does nothing and just continues. The return value of undefined is just because our test is full function doesn't return a value. All right, so let's make a similar function here of just it's a little bit. Oh, can you see that? It's a little small. Console.assert is full. Now let's actually pass it a full array that's full of x's. Oops, sorry. And that should be true. And we'll say this is a full of x's. Okay, we'll save that. Run a test function over in Chrome DevTools. It also says undefined. But you know what I find a little bit unsatisfying with this is that if my test was broken and it say like it was just return, what if I just had a return right here in the beginning of the function? I'd go run tests. I run my test functions here. And it looks exactly the same. It's not very good because you don't have really confirmation that the test is really run. So let me refactor this a little bit. I'm going to write a little helper function that will just kind of give us more positive confirmation that each of these tests are succeeding. So let's write our own kind of like assert function. I'm just going to call it assert. No, I can't call it assert because that's a built-in keyword of JavaScript. I'm going to call it assert count. How about now? Assert is true. There we go. And it's going to take a Boolean value. I use F for Boolean. It's kind of left over from Microsoft days. That means like flag, but it's pretty common. So what all this function is going to do is it's going to call console.assert. Oh, and we're going to take a optional name of the test. So console.assert f and name. I'm just going to call that. And then instead of this one, I'm going to call assert is true, our own little helper function. Now I haven't changed anything yet. I just put it inside of a helper function. So this should do pretty much exactly the same thing. But what I'm going to do now, let's create a variable that's going to count the tests. Test count equals 0. And every time we call this function, we'll increment the test count. And then at the very end of this test, I can log out what the test count is. So let's put something in here that says something like display test count, and that'll be another function we're going to write here. And it's going to console.log. Actually, let's do how many tests passed. There is a tricky way in JavaScript to embed numbers inside of strings. S. So let's do it. Let's have a passing count. Pass count. So it's like a total count and then a passing count. And say if this is true, then I'll increment the pass count. Now some people don't like this plus symbol. You could also do plus equals 1. It's maybe a little bit more descriptive, but either way works in JavaScript to increment a variable or add one to the variable. So we're going to increment our pass count, and then we assert that is true also. So here we're going to say pass count out of test count tests. Okay, so that should display what was actually, how many times we called assert and what their counts were. Oops. And I'm sorry. Test is full. What's going on? Oh, did I end up with a bug debugger breakpoint here? Okay. Test is full. Call a function. that doesn't work in this. All right, I think I'm using an older version of JavaScript. Actually, I think I just used the wrong. If you use the double quotes, you have to use a back quote for the string. If you're going to use this is called string interpolation, and it puts that's where it will look for these template things and insert those expressions inside the middle of our string. So let's try that is again. There we go. Passed 2 out of 1 test. Well, that doesn't look right. How would you pass 2 out of 1 test? It also says out of 1 test. Let's see. Oh. Our test count is 1. Pass count is 2. How is that possible? Well, let's set a breakpoint and see what's going on. I can now call let's set a breakpoint at our test function. Test is full. Okay, we have a breakpoint. Now we can look at some of our variables. These are global variables. I think, ooh boy. Oh, just in this window. Here we go. No, that's not right. Yeah, they're in here. Test count is 1. So it already has a test count of 1 because it's left over from our previous test. We ran it twice. So one thing's after we finish displaying, we should maybe reset these counts. And we should continue this. And now it has pass count is not a number. Okay, I think I just refreshed the browser. I think maybe I had an old window. Test is full. I have set a breakpoint here on pass count. I can see both test count and test count is 1, pass count is 0. Continue that. I have another breakpoint, and then test count is 2 and pass count is 1, and it finishes with passed 2 out of 2 tests. So, okay, we have confirmation that our test finished now. Okay, so great. So now we have two tests, and we should probably test something that's not quite as obvious. Like we're gonna run through several different test cases. So let's try a board that has a mixture of 1s and 0s, or yeah, of 1s and 0s in there. So it's full, and make sure that case works. So say oh, that is hard. That's hard to see with the. Let's see, I have 3 1s there. I'm gonna add a little bit of space in here so I can read these arrays. First row, second row, third row. Okay. Oh, and stop it. sometimes the ID gets a little bit in the way because it inserts characters for you. Okay, so this we expect to be true. And you know, I'm going to change my assert. I'm going to change this to an assert equal instead. It's maybe a slightly more useful function. And we want to say that this thing is supposed to be false. And this thing is supposed to be true. And then down here, we're going to say if. So here we're going to have a value and we expected value. And so here we're going to say if the value is equal to the expected value. And I'm going to do an exact equal. JavaScript has this weird thing where a regular equal will compare two things that aren't actually equal because they look similar, like a string a number 1 and a string of the digit 1 will compare as equal, but that's generally not what you want. So you should always use triple equals for comparisons in JavaScript. So if L is expected, we're going to pass, and otherwise we are not passing. And instead of console.assert, I think there's another one that just says we got an error. Console.error. There we go. And we're just going to pass in that name. All right. So that should be our function. Oh, and then this is called assert equals now. And we have something wrong here. Oh, because I didn't finish this. Assert equal. And this, oh, stop it. This is supposed to be false. And I'll say mixed board. That. Oh, I missed a parenthesis right there. Okay. Get rid of that breakpoint. Continue. Pass 3 out of 3 tests. Okay, that's good. That one works. And we also don't have like X's and O's, a combination. That would probably be a good thing to test. Is full, and I'm going to make it full of X's and O's. So 1, minus 1, 1, minus 1, 1, 1, minus 1, 1, minus 1, 1. And that should be true. And mixed full board. I've got an error here. What's going on? What does that say? Expected a dot? What? Oh, yeah, I didn't put this in an array. So this is an array. Here, beginning the array. There we go. So test is full here. Pass 4 out of 4 tests. Okay, great. So now, now you can see that we have not only some code that's written, we actually have a lot more testing code than our real code. This is our real code up here, and these are all testing helper functions. Testing functions. We'll go down here, and then these are testing helper functions. And the top is our actual code that we're trying trying to make run. Okay, so now we have that function. Let's go ahead and write, you know, what I think is going to be the main function that we want. Actually, I changed my mind. Well, let's write a function that will look at a board and tell you whether one side or the other has 1 or not. X's or O's, you know, or 1 and -1. Which one is won the game? So the function would be has 1, and again, it's going to take a board as a parameter. This time, it's going to return a 1 or a -1. So returns 1 if X wins, -1 if O wins, and 0 otherwise. That's what this function's supposed to do. Okay, how do we do that? Well, we have to see if we have 3 in a row in any of the positions, which is maybe a little tedious. If we could write if statements out for each single one, like if board, we could say if board of 0 equals the board of 1, and also if that same value equals the board of 2, okay, then we know that that is, stop it, that is a case where that the value of that piece is, oh, I put 3 ands, that's not right. The value of that, the top row has all X's or all O's, and we return a 1 if it's X's and a -1 if it's all O's. It's kind of tedious to do that way. So I'm going to create a little table, and we're going to keep track of how, you know, where the actual ranks of positions on the board are. So let's create an array, and it's going to be an array of arrays, actually. So the first element of this array is going to be 0, 1, and 2. So like that's the top row. Let's list out the indices of the array for all the rows. We have either 0, 1, or 2. The next row is 3, 4, and 5, and the final row is 6, 7, and 8. Okay, and what about the columns? Well, we have 0, 3, and 6. Kind of refer back to like the original drawing I had of, I don't know if that's not there anymore. And then you have 1, 4, and 7, and then 2, 5, and 8. So those are the indexes of all the columns of a tic-tac-toe board. And then we have the 2 diagonals. So let's list what those are. That'd be 0, and then the middle square is 4, and the lower right square is 8, and then finally the other diagonal, kind of the backslash diagonal, is 2, 4, and 6. So now here we have an array of arrays. So there's each of the elements of this ranks array is a 3-element array itself, which has the 3 indexes of the board positions. So to use that, we can loop through all the different ranks, and we can see which one is, see if any of them are all equal, and yeah, and then we could return that value. Now, another kind of a tricky way of doing that is to add them up. If they're all 1s, they'll add up to 3. If they're all not -1s, they'll add up to -3. And then we can just return that too. So let's go ahead and do that. So we're going to say for I equals 0, to ranks.length I plus plus. So this goes through all of the ranks itself. So we're going to have, I'm going to call that, it's going to be one of those arrays. It's going to be rank sub I. That's going to be the array that's in there. And then we'll just say if the board at rank 0, so I'm going to get each of the digits out of that rank, that 3-element array that I'm calling rank has 3 indices in it, and those are indices into the board positions. So I'm going to add all these up. Board of rank of 1, and then plus board. Let me go ahead and make another variable value here. I'll say the sum equals this stuff. Board of rank of 0 plus board of rank of 1 plus board of rank of 2. Okay, so now that's the sum of those 3 things. If it's 3 or minus 3, then we have a position where somebody has won a game. So I could say if it's 3 or minus 3, but there is a function called math.abs. So you take the absolute value of the sum, and if it's equal to 3, then we're going to return whatever value is one of those elements. So we'll take the first one, because that'll be a 1 or a minus 1 in that position if we have a valid board. Okay, so this is garbage here. Don't use this anymore. So that's if there is a win, this loop will we'll find one of the wins, and otherwise, if there's no win, we're just going to return a 0. Okay, let's see, and that looks good so far. So we can try the has1 function. First of all, let's take a look at the ranks array. Let's see, you see it's an array of arrays, and if I look at ranks of 0, so that's the top row. Ranks of 1, that's the middle row. So if we say has1 and we pass in a board which is, let's say it's going to have x's on the top row. And it says 1. The player who has a 1 there wins. The X player wins. What if the Y player wins with a diagonal win, like that? -1, 1. Okay. And what if nobody has a win yet? Oh. That's not good. What happened? So I have an error where I used I'm not sure what happened here. Let's see. I can set a breakpoint. Let's try debugging it. Okay. I'm going to step through this. This function steps over one thing at a time. So I haven't hit an error yet. The I is equal to 0. There we define rank. We get the sum as 1, which, because it's 1 plus 1 plus minus 1, which isn't anything. So we're going to keep going. And we have I. Oh. Okay, I think I see my problem. This for loop is not written correctly. You have to say I is less than ranks.length. So the total number of ranks in there. Okay, let's refresh this. So turn off our breakpoint. Do has1 of our board. That's -1. That's the one that worked before. And this one, Okay, nobody wins, it's a 0. Okay, so I found a bug in just ad hoc testing. So to make sure our code never breaks again, too, you want to add more tests for this function. So I would say I'll write a test for has1, and very similar to what I had over here, I can kind of copy these examples here. Here was one where we expected -1 to win. So I'm going to search equal has1. That should be -1, and it's O diagonal. That's the name of the test. If it fails, it'll print that out. And then there's another assert equal. Yeah, this one should be nobody1. Copy that code out of there. So that should be a 0, and that's no winner. Okay. And that's it. But we have to call 2 separate functions. So let's add another function here, which will run all of our test function. We'll test all, and it's just called test is full, and test has 1. That's what that do. And another thing I think might be nice to see is to see that we are which tests we're running at the time. So I might say start test is full. Let's try to, and then instead of display count, let's say end test, like that. And we'll do that again for this one. Start test has 1, and end test. And then what we can do in our helper functions, start test is going to take a name, and let's just console.log, and we're gonna use a string that says testing our name. Okay, that's how we start the test. And then for end test, why don't we take our, actually why don't we set these to 0 at the start of every test? Why don't we set these global variables to 0, and then here I'm going to say, well, the end test is pretty much just going to display how many passed or how many failed, or out of how many tests were in there. That'll be good. And let's just put a little some space in there to indent it a little bit. And let's see, how does that work? Test all. There we go. Testing test is full, passed 4 out of 4 tests. Testing test has 1, passed 2 out of 2 tests. Beautiful. All right, so now we have 2 functions that we are pretty confident work, and because they're being tested. If I wanted to break one, I could put like a bogus value here. Like what if I said this is supposed to be 7. And now we try to run this test again, and it says, the test no winner failed. So that is one I don't want, and I think I can change this to name failed, so that I can see that assert actually, instead of the, because we had an assert before, but now this will tell us that no winner failed. And then, further, because this is an equal test, I can actually say what two things were not equal, and I could say val is not equal to expected. Okay, so now my string, if I run that test again, there we go, no winner failed. 0 is not equal to 7. So here I said I was asserting that has 1 should return a 7, but it returned a 0. So it tells me now exactly why it failed, because 0 is not equal to 7. Great. I'll fix the test to be the correct assert, and there we go. All the tests are passing. Okay, great. All right, so now I think what we want to do next is write a function which will tell me where is the best place to move. And to do that, let me go back and draw another picture about how to play tic-tac-toe. Okay, if we're going to write a game that determines what the best move is to make, we're going to have to search through all the possible moves and figure that out. So, and the way you organize that is kind of like a tree pattern. We're going to, so suppose that the very beginning, the very top of the tree represents, a position of the board, like say that's the board. So what are the possible moves we could make? We could have a board that where we move to the upper left square, or we could move to the center square, or we could move to the far right square, etc., etc. So there are like 8 possible moves. So all 8 of these would be possible moves to be made by the O player. But then for each of those boards, there are places that the X player can move. So it starts out with that, but then the X player could answer with that, or the X player could answer with that, etc. So you end up with this tree of possible moves. And at the very bottom of this tree, you come to a point where maybe one player has won, and then you can, so you've found a win for one player or the other. And let me just see. If you do this in the way you do this in code is that you think of this tree as having different layers of depth that you're searching. This is basically called a tree search that we're going to do. So at this top level, you're trying to get to a value of 1. So we're going to call that maximizing the value of the game. So if, say, the game has a value of 1 if you win, 0 if it's a tie, and -1 if O wins. So 1 if X wins. So the X player wants to maximize the score from this position if he's the first to move. And then the the O player was trying to minimize the position of the board for all of the positions that are the next level of the tree. And then the X player would then want to maximize those. So you have these competing interests where each player is trying to do the best that they can given the situation that they are given. And what we're looking for is a particular at the very top level, we're looking for the next move that is going to be the best possibility. So if I move here, can I get a win from this value? And you know, maybe this one is a win, and this one's a tie, and this one's a tie, and this one's a loss. So you would want to choose this one, and you only know that because you know that somewhere down here in this tree there is a win for X, and no matter what O could, no matter what position O would be in, like every possibility at that last stage was that X was going to be able to win. So that is what we're doing, and we're going to use recursion to implement this. So let's go back and write some code. Okay, first of all, let's explain recursion. I'm just going to put some stuff at the bottom of our code here, just so we can go through and understand what recursion is, in case you haven't seen that before. So instead of writing a loop, you can use recursion to define how to go through several different things, and you can define a function in terms of itself, which sounds impossible, but there's actually kind of a trick to it. So one way to explain recursion is with a sample problem called the Fibonacci sequence. So Fibonacci sequence, if you don't know it, it starts off with 2 1s, and then the next value of the sequence is the sum of the previous 2 values. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 is 8 is 13, and then 8, 13, 21, etc. So those are the Fibonacci values. So how would we define a function that would return the nth Fibonacci value? Well, if n is less than or equal to 2, so it's like number 1 or number 2 in the sequence, we are just going to go return the value 1, and that's it. That's done. So right there, the Fibonacci knows how to return those first 2 values. But if it's one of the greater ones, well, I don't really know what that number is, but I have this function where it knows what the smaller values are. So I can return the sum of Fibonacci of n minus 2, spell that right, added to the sum of Fibonacci of n minus 1, like that. Okay, so let's try that out. Fibonacci of 1, good. Fibonacci of 2, good. Fibonacci of 3, look at that, 2. So it ended up calling Fibonacci of 1 and Fibonacci of 2 and then added them together. Fibonacci of 4 will do the same thing. So we can do Fibonacci of 8, get 21. Fibonacci of 20, 6,700. So we can get any of those Fibonacci's. Now these are actually calling like a lot of Fibonacci's as a way of optimizing this, but just for understanding recursion, that is how you define recursion. For a recursive function, you always have what's called the base case. So at the very beginning, you have to have something in order for this not to loop forever and ever and ever. It has to have a case where it will always return a value. So here, in case n is smaller than 2, it always returns a value 1. And if n is larger than 2, it returns the values of the Fibonacci that are smaller than that. So you're always guaranteed that eventually this will return, because at the bottom level it's going to return. So how do we use this how to use that kind of idea of recursion to solve for tic-tac-toe? Okay, so let's write a function that's going to find the best move. And this is kind of the crux of our tic-tac-toe game playing function. It's going to take a board and a side, let's say like a 1 or -1, depending on which player's next to move. And let's return something that looks like a position, and we're going to return a position and a side. So the side would be who won or not. So is there if there's a win for X, we would return side of 1. If it's a loss for X, we would return side of -1, or it's a win for O, etc. Or 0 if there is no if there is no position that is a winning move. So let's go ahead and take a look at that. Let's see how would we do this. Well, so there's a whole bunch of, we want to go through all the different board positions and see if there's a way we can win or not. And compare all the different ways that we can do that. So let's make a loop. We're going to loop we're going to loop through all 9 possible. Sorry. We're going to loop through all possible 9 board positions. And first of all, let's just check if that board position already has a piece in there. We can't move there. So we're gonna break out of that loop and just continue on to the next value of the loop. So that in a for loop, continue just will go around and get the next value of the for loop. So we'll try the next position. Okay, so now we're going to try this. We're going to try this board position, and we're going to say we're going to do something like do a actually let me change this. Okay, so how would we detect that we've already lost the game and there's no move we can make? So remember we had that function has1, which takes a board, and if it's equal to the negative of our side, that means we've lost already, and we're going to return now something where the position is undefined, because we're not going to have a position, but the side that won is the minus side. So that is what we return there. Okay, so that's the case where we've definitely lost. We've already lost the game by the time someone's calling us to ask what the best move is. The other thing that could happen is the board could be full. I'm not going to test the case where we've won, because I think that probably will never come up. Like if the game has already been won, we will not be calling this function ever again. So I don't think we have to do that. We'll see. But what if the board is completely full? So if is full board, well, in that case, nobody's won. And again, we're going to say, there is no position that we can return here. Oh, I need to use commas for this. So what I'm doing here is returning an object which has these 2 named properties, pause and side. So that's what this notation up here means. So I'm returning just an object that has those two values. It's a way of returning 2 values from a function instead of just a single value, because the object has 2 values in it. I'm really returning 1 object. Okay, and nobody wins in this case, so side 0. So that is a tie game. Okay, so now if we haven't lost already, and it's not a tie game, what do we want to do? Well, we want to try all the possible board positions that we can, that are legal to put a piece on it, so there can't be anything else there. And then we're going to see what how how good was the position for our opponent? What is the best he can do? So I'm going to say we're going to take a result, which is find best move, or call ourselves recursively with this board that we've modified. Oh, actually, we got to modify the board. Let's go ahead and make a move. So we're gonna make our move at the position, and we're just gonna set it to side, which is our side. So this is be a 1 or a -1 going into the board position. Then we're gonna find the best move that our opponent can make from now that new board position. So he might have already lost because we just made a move. So he might have already lost, like here. He'll run that code, and he'll return to us the value of side that we've won the game. So if this result is a win, then we are done because we found a winning move. So we don't need to go around in this loop anymore. So we can say return position of position, our variable. In this case, the thing on the left is the name of a property, and the thing on the right is the name of a local variable. And then the fact that we win here as well. So that is what happens with that. But one thing I did forget is we need to restore the board back to the way it looked before. So there was a 0 in there in the position we tried out. So we put, like, for example, an X in that position, then we find the best move that O could make. And then when he's all done, he's going to return, and then but we want to restore that move in the board and not leave it there, so not corrupting the board for the person who called us. So put it back in the same position we had it before we return. So yeah, so if we win the game, then we'd return that. If we haven't won the game, then we need to kind of keep track of, well, what is the best we can possibly do? Do we have any ties? And we want to avoid the losses. So why don't we keep track of whether one move is better than the other? Okay, I'm just changing my mind here. I cut out a dead end. We want to return, we want to keep track of the move as the best move we've seen so far in 2 cases. Either we've never recorded a move before, in which case the value of best is going to be undefined, or we found that this move will give us a tie, which is going to be better than a loss. So if we have a tie, we could go ahead and, and if we haven't had a tie before, like if we're currently losing and then this move is a tie, then that would also be a good move to do. So we're going to make another test here. So if our best is equal to minus side, so that means like we're currently losing, and the result that side is a 0. So if the result that side is a tie, then we're going to want to use that as our move. So then we record the best and the best pause now, and that'll be our move. If we don't find anything better, like if we don't find a win somewhere else as we iterate through all the positions. So if we go through all the positions and there are no wins, we just have to return the best we can. So we're going to return the position, which is the best position, and the side, which is the value of best. And that's it. So, and this is guaranteed to return something because the board wasn't full. So there will be some position on the board where we will find a move to make. And and so we will always return something. All right, let's test this out. Okay, it's a new day, and I'm coming back to continue our tic-tac-toe tutorial. So we have written this code for, let's show the code here. This code for, looking on the right side there, the find best move. There we go. But I think there's some problems with it. Last time I ran it, I tried like the first move on an empty board, and the return results seemed to indicate that it thought we would actually win, which I know the correct answer is that we should actually just tie. So let's see. Yeah, it said I win by moving in the center square, which is not really true. So we know there's a problem here. Now here's the problem with debugging this. I could debug this, and what we do is we'd set a breakpoint here, and then I could do the same, execute the same function again. Oh, wait a minute, what's happening? Why didn't that stop? Oh, it says pause in the debugger. Let's see. Let me continue here. Actually, I think we're hitting a lot of breakpoints. Let me clear all these breakpoints out. Continue. Okay. Now set one breakpoint right here at this line, the first line of our function, and we'll start. We'll type in finding the best move on a board. Now we're starting out. Here's find best move on a totally empty board. Problem is, this is going to have multiple levels of recursion. We're going to call this function over and over again. If I continue this, you see, well, we're finding best move. What if X moved in the upper left corner, which is this one here? Now what's the best move for O? And then we're going to do another one. Oh, okay, now, so O is trying out moving in the next square over, and we're trying out something there. So I can continue this way, and just we're kind of searching through all the possible boards deep in that tree, but we have a long way to go before we ever come up with an answer back all the way to the top level. We're kind of searching all the different variations and permutations of moves all the way to the end of the game. So it's pretty hard to debug. So let's try a simpler example. Like the best way to do this is starting off with the simplest examples where there are as few moves as possible. So let's just stop this. We'll turn off that breakpoint, and it's better to try a simpler move. So what would be the simplest move? I think we want to do something like where maybe there's only one move on the board possible. Just make sure that we actually use that. So I'm just going to fill this out with I'm just going to alternate X's and O's. X, O, X. And then the next one, O, X, O. And X, O, X. Oh, no, sorry. And then 0. So like the only thing available is the last square. Now I wonder if I have the right number of X's and O's here. Since X, 1, 2, 3. I have 4 X's and 1, 2, 3, 4. Yeah, 4. I think I have 4 O's. Yeah. Yeah, so I think it's X's turn to fill in this last square. And let's see what we get. And it says, well, move an O to the last place. So that works. We said move X to the last position on the board. And yeah, we like that. So now I can start going through multiple test cases, but it's going to take me a while. So again, let's go back and add a test case that we can just run over and over again instead of typing them in by hand. Okay, so what do we want to do here? We have test as 1, test is full. Let's add another one, which is kind of a more sophisticated test. What is it called? Find best move. We're going to write a function for that. And use the same pattern of how we were doing that before. Test find best move. And first of all, we're going to call it say start test. And this is the find best move test. And at the end, we're going to end test. If we just ran that now, test all. I had a typo. Test find best move. Oh, I forgot to put capital there. Okay. There we go. Test find best move, but it passed 0 out of 0 tests. So that means we have to add some tests in here. So, let's see. We had. I'm gonna make a variable here called the case. So we're gonna fill out the same thing we did in the manual test. So 1 0 1 minus 1 1 minus 1, and then 1 minus 1 0 at the end. So that is our test case. And then I will say result equals find best move, pass in the test case, and we're going to move as x. And now we can assert equal that the result, remember we have a result dot pause should be equal to 8, and and we're going to say let's say first case number 1, and we're going to say correct position. And we should also test that it actually did move an x there. So we're going to say the result dot, what do we call it? Side is the 1. And we'll say this is for test number 1, correct side. Okay. Let's make sure that find best move does return, yeah, position and side, right. So we have a syntax error here. Oh, let's see. So in my, I said, oh, case. The word case is a keyword in JavaScript. I can't use that. So test case. It's for a switch statement. So if you don't know what that is, you'll be using that quite a bit. Okay, test case and result. Okay, how's that? If I save that, I'm missing a on line 84. I have a, oh, there it is. Oh, what? Oh. An extra parenthesis in there. Okay, so now it compiles, or it parses all of that without finding any syntax errors. I think. I don't know what that is. Restart to update. I don't know what it's doing. Okay, maybe it's part of something I was doing before. Let's go back in here and we're going to go test all. Find best move. It works. It found that best out of 2 moves. Now let's try another case where let's see if we can kind of work out where, eventually we want to work our way up to that more complicated case at the beginning. But let's try another one where we're going to say this test case is equal to how about we have it choose something where there's 2 possible moves. One of them will win the game and the other one will not win the game. So should maybe draw a picture. Okay, we'll do some examples. Let's see. So what I want to say is, let's say we want the last square to be something here. So maybe we have something like that, where first move is in the center, and say there could be a lot of possible moves, but we want to make sure that X tries to go here, and let me erase that one. Yeah, this is not an O there, but this is what we expect X to try to go into this position. So let's put that in as a test case. All right. So our test case then would be, we had a -1, 0, 1, that's the top row. Then we had 0, 1, 0, that's the middle row. And then the bottom row is all zeros. Okay, and so what do we expect when we do that? So we're going to say result equals find best move of our test case with X to move next. And we're going to assert equal that the result dot pos should be 0, 0, 1, 2, 3, 4, 5, 6. And assert equal, of course, again, that the result dot side has to be an X that it's putting there, or a number 1. Okay, and see what happens when we run our test again. Okay, it failed. But because it says undefined failed, oh, it's because I didn't give it the name of the test. Let's see, assert equal. We're going to say this is test number 2. Correct position, and this one's going to say test number 2, correct side. Okay, run the test again. Correct position failed. So it tried to move into position number 1, which if we go back to our where's our what happened to oh, iPad powered off. Oh, come on. Ah, there it is. Okay. Position, so it moved an X here. Okay. You know, I think it's not a wrong move per se, because in that case, you know, you're still guaranteed to win because you have 2 different ways to win. So it might still be correct that that's, by our definition of winning, moving in this position up here is okay, because it still would win eventually. We didn't put in anything saying, oh, I want to win as quickly as possible. So let me just change the test case here so that we don't hit that particular glitch, and I can make a case that will definitely work right. So I think what I do is, like, how would if I start off with the X being here, and then we'll just make sure it moves up into the, or actually, you know what, even, yeah, I move the X here and it'll move into the 1 position. It should see the win and move into the 1 position here. So I'm making kind of like a little bit of an easier test. So this would still be there. This one though, oh, the center is there. Oh no, so instead of this being an X in the corner, I'm going to put an X down here. And then we'll run the test again. Oh, wait, what? Oh, and then the position though here, now I think the position should be position 1. Okay, and it passes. Okay, so there's another simple test. So in general, we're going to start adding tests like this and getting more and more complicated, and then fixing the code to make sure that we get the result that we want. Like I think in this case, we do want to fix this test here that I have failing. But let's go back and change our. I think I wasn't showing you this code. Yeah, so here's where we changed the code to do that last test. let's generalize this thing. So we're going to have a whole bunch of tests, and there's a whole bunch of redundant code here. Let's change it so that we actually have a loop of test cases, and we go through all the test cases. It'll be less code as we start to add more and more cases of code here. So I'm going to call this, I'm going to say test cases. Test cases. And it's going to be an array of test cases. And the first test case, I'm going to, let's make each test case an object. So because we're going to have to put in the board we want, and then the position and side that we expect it to return will be the two cases, or the two properties here. So we're going to say the board for this first test case is that, and then I'm going to say I expect to see, and then I'm going to expect two different things. I'm going to expect to see the position, which is, what did we say? Oh, this is the first test case. Yeah, this is the very first one. So I expect it to be position 8 and side 1. So that is kind of the whole test case. It describes the input and then the expected output. Let's add another one. We have another board. Did I close this off properly? Close that object, and then a comma. Yeah, oh, yeah. So it's just, this is going to be a list of objects. So objects have properties, and we can just set these properties here. The first property is a board, which is an array, and the second property is another object, which has two properties, which is a position and a side. And let's just put the other one in there. The other test case, we're going to move it up to here. And for this one, we expect, it's not formatting the way I'd like it to be. Stop it. I want it to be like that. Okay, I expect the results to be the position of 1 and the side of 1. Okay, we're going to try to we're like refactoring this code so that we can have a loop, and then we can just add test cases as simple as adding boards and expected results for each of these. Okay, so we no longer have this test case variable here. We're not using that anymore, and we're going to instead, we want to loop through all the cases. So we're in an index of test cases through this array, and then we're going to have our test case is going to be test cases sub I dot board. That's what we use as the test case. We're going to have the result, like before, which is find best move using our test case, and the side, test case sub I Oh, no, we didn't put the side that we're actually putting in there. But it is actually the same thing as the result. Like in all cases, we expect the side we pass in to be the same as the side we get out. So maybe that was a little redundant to actually have it return that. But that's what we have, so I will go ahead and just make it the same. Let's see, can I expand this out a little bit? Let's say somebody expect dot side. Maybe that's a little confusing here. Okay, now we have our asserts. We can assert that the result dot position is the same as the test case dot. Oh, these are really annoying. Aren't they popping up, covering my code? Oh, I don't need this I here. it's just a single test case. Sorry. It's the test case dot board. You know, I can do it this way. Test case is just one of whichever the current test case is, and then we'll find the board and then the expected side. Okay, and then it's test case expect pause, and then like before, we're gonna a weird character. Let's put the we're gonna use that string expansion to put in the test number that we're using, and then we say this is the test for the correct position. And then we have, maybe if I do it up here, I get those things to pop down below my code instead of on top of it. Result dot side. We expect it to be expect. Yeah, this is really annoying. Test case expect side, and this is the test. For the error message, we're going to use which test number it is, and say this is the correct side. Oh man. Okay. Sometimes the ID gets in the way. Like it types stuff ahead of you. It kind of recommends things, and it can get a little annoying if you're not really working around like what it's auto typing and what you're typing. So anyway. I am hitting some issues with that. So now all this code is really been duplicated up here. So we're doing the exact same test, except we're doing it with a loop instead of typing it out manually. Okay, and I have an error in my test. What is the wrong with it? Let's see, it's line 92. So what is the value of let's set a breakpoint here, and we'll do the test again. And what is my test case? It has a board, which is an array. That looks good. But why is it, what is it saying is wrong here? Says yeah, that's all looks, oh, that all looks right. Why doesn't it like it? Oh. Yeah, that's right. There's a little red squiggly here. It's telling me something's wrong. What is it saying? Cannot read property board of undefined. Where is it trying to read board of undefined? Because I have this variable test case, which is not undefined. Oh, maybe it was in the second the second case. It was an error. That looks fine too. Oh, yeah. Here's my problem. I screwed up this loop. I need to test for I less than length. So it was just testing whether it had any non-zero length, and it was just going to go running off and doing millions and millions of. It was going to increment I, but never test that I was going to stop this loop. So now I fixed the loop. Okay, let's see if that works. No. All right, that's more like what we expected. And if we wanted to fail this test, just to, I'll just to make sure that our error message comes out okay. Let's do that, and come on, test all. Wait, what? That's not right. We're gonna refresh on that. That should fail. It's not failing. Oh, it doesn't say it's passed either. What's going on? Okay, so let's set a breakpoint. Let's see what happens. This should fail. I'm going to refresh, make sure we have the right code here. Set a breakpoint there. Test all. And we hit this breakpoint. Okay, so if I jump over that, oh, there it failed. Maybe I was just hitting a breakpoint and not running the whole code. Yeah. And then run it again, run it again. There we go. Those both failed. 8 is not equal 9, 1 is not equal 2. So yeah, that's what I expected. Let's go back here, reset this breakpoint, and just make sure all the tests are passing. Find best move has 4 tests. All these assert equals called 4 times, and it's succeeding. So that is good. Now we can add more tests. And we can find one, the simplest one that fails. So let me think about that for a minute. Okay, let's think about a case. Now, what is our code is doing? Whenever we're presented with a situation, we are we're stepping through and looking at each of these spaces in order. So we're almost always going to try this step, you know, if this space is free. But let's try a situation where what if you know, it's somewhere in the game I had moved here instead, and O moves here. So now we are in this situation where X must move here to the next space, but it's going to try this one first, then this one, then this one, then this one. All of these should be losses for X, so it should, except for moving here. So I think that is a good test, and it won't have that problem with trying to find the shortest win. But the only move in this situation should be to move into this position down here. So let's encode that one as well. So here we had that board. Oh, stop it. I want it to be lined up. This is weird. All let me try that. See if I can get the editor to line up the tabs for me properly. Oh, that's very weird. Okay, I think that's right. So everything's lined up. Okay, yeah. All right. Okay, so here we want the board to be -1. That's the O in the upper left corner, and nothing else there. But then we're going to have another O in the middle left position, then 2 X's, and then everything else is 0. And now we expect that this is going to return a position of, we want that lower left corner, which is 0, 1, 2, 3, 4, 5, 6. And of course, it's the X that we expect it to return. Oh, let me put the end of the object here. Okay. And I can always, there's a style of just putting a trailing comma at the end of a list. Just so that you can add something new. You could paste something new in next time, and without having remembered it, you need to separate them with commas. So I put the extra comma in there, which used to crash JavaScript long ago, but now I think it's all fixed everywhere. You can add that trailing comma. All right, let's try that. Test out. Save that. Test all. Ah, it didn't have the correct side for test number 2. Oh, you know what? When we say test 2, it's a little confusing because it's starting with test 0. Let's call it test number 1. Let's do a 1 base test. So test number 3 is returning a side of 0, even though it's X's turn. Well, that's totally wrong. So that is wrong. That's really weird that it would do that. So that's something we could debug, I think. Let's see if it's, hopefully it doesn't get too complicated to do that, because it's have to go through 2 other steps. You know, it could get a little complicated, but let's try it. Let's try to narrow that down in the debugger where it's making that mistake. So let's set a breakpoint here. Oh, actually, let's set a breakpoint in our test first, and we're gonna only really care about the 3rd test case. So we'll run test all again. So it's the 1st test case, 2nd test case, 3rd test case. Okay. So now we step over that line, and now we want to step into the next function. So this little down arrow here means step into the next function. There we go. And we can set a breakpoint at the beginning of find best move here. So let's confirm, you know, what we're looking at is here. Let's see, let me shrink up this window here a little bit so I can have more room to show what's going on. What's that going to do? Can I hide this? Oh, I don't know how to hide that panel. Okay, so we're calling it with a board that is, yeah, the O blank blank O XX, and we expect to move here. So let's just step over. Let's step down through there. We have nobody's won. The board is not full. It's going to start going through positions, and I'm just using the step over command here to run through this, and I can turn off this breakpoint. So I'm just going to step over all the functions. Now we have we keep track of, we're trying position 1 now, and the find best move there was that yeah, our opponent is going to move to 6 and win, which is right. So that's correct. If we move there, we're gonna lose. And then let's see, we're going to say our best move so far, which is our only move so far, is that one. So best and best pause. So at best we're going to lose, and our best position is 1. So that's good so far. Let's try another position on the board. We're going to try position number 2, and should be the same result. Our opponent is going to win by moving in 6. Okay, that's correct also. So that's that. Now from here we're going to try some positions that are already filled with squares. So position 3, 4, and 5 are filled, so they can't even go there. So this little continue should at the top of our loop should trigger, and we'll eliminate those moves as illegal moves. And now we get to position 6. Here's the move we should be making. And let's look at our board, make sure, yeah, 6 is open. So we should be making a move at position 6. And here we're going to say what is O's best move if we've blocked his win. And I would expect him to move like position 1, so that he would get potentially 3 across at the top, something like that. Let's see, what did it return with? It returned position 2 and said that it was a draw. Well, that's okay. So it says it's a draw. And this is better for us. Like right now, our best move is a loss. So let's go through and see why we're not replacing best with this move, or if we are. So here I'm saying, like, did we win? And we shouldn't have won. No, we didn't win. But we did say our best, you know, so, oh, here, there were, if I said if, oh, if we were losing before and the result of this one is a draw, we want to replace it. So this is exactly what we're doing. So here our best is the result.side, and best pause is 6. So yeah, we got the best move now. So somehow I think we're returning the wrong move somewhere else. Let's see. So we did find the best move. Let's take a look at the next two. We're going to try position 7, and that should be also a loss. It is. So we should go down. We shouldn't change this one at all because we have our best hope so far is a draw, and this one is a loss, the one we're considering now. So we shouldn't take that, and we don't. Okay, and then position 8 is a loss, and we shouldn't take that. And then we're all out of trials. And what are we returning? We're returning what I thought we should be returning. Position of best pause 6, and 0 as a draw. Okay. That seems like the right thing. Let's go back. And here I'm expecting a 6. I have a 6. Oh, wait a minute. Oh, but the side is a 0. Oh, it's a draw. I'm expecting a draw. So my test was wrong. Test is wrong. Should have been a draw. I forgot about that. It returns a 0 for a draw. So this whole time I just had a wrong idea about what the test should be. Let's go fix that. And I think, you know, our little test case thing needs to be adjusted as well. Let's see. So when we need both the side we were going to pass in and the board we're going to pass in. So let's call this the input is bad. Let's input is the name of another JavaScript function. Let's just call it in. And in is going to have, we don't need to do that. We have a board, and then we also have a side, which is 1. So these are the inputs, the board and the side. And so all these tests, the side is 1 that we're going to pass in. But in this case, the result we expect to get is a draw. I'm missing a comma. There we go. And so here, our test case side, test case board, test case side, and then expect those sides. So that I think is what we want. Let's turn off this breakpoint, refresh. And let's try our test again. Now we pass. Okay, so that simple test pass. So still, as far as we know, we haven't found a fail. Well, I wrote a bad test. That failed, but I fixed the test. So we haven't found any bug in the code yet. So let me think about another test. What would the next most complex thing to be trying? So let's think about games that the computer would play. I think it's going to start X, I think, as this first move, because we know tic-tac-toe will always result in a draw if both players are playing optimally. So, and moving in the corner square can yield a draw. So I think most players would play the center square as the first move, but our algorithm, I think, doesn't distinguish it. So I think it'll go there. And I think the next move, O will not consider moving here because that would be a loss, I believe. So I think O should consider moving that. But then X would move here, and then, and let me write these down. This would be the first square that would be move to. The second one, this is the third move. Then O is going to answer here as the fourth move. X has to go here as the fifth move. O has to go here as the sixth move. Then I think X would probably go here as the seventh move. O would go here as the eighth move. And then finally X would finish the draw game with the ninth move there. That's what I think the order would be. So let's go back to the code and see how we would test for this. We could do like a lot of partial games. Like we could put in this board position and work our way backwards. Like, what is the fill in the first 8 moves, and then make sure that the test matches the ninth, and then fill in the first 7 moves and make sure it does the 8th and the ninth in this particular order. Or we could actually just have a little loop that runs through a full game and seeing, like, from a given starting position, how would the game play out until it's over. And we can test for that, and we can test like what the sequence is and what sequence we want the game to be doing. So let's go ahead and do that in the code. Let's take a look at that. So I think what we'll do is we'll have a new test, which is called, well, let's have a new helper function. We're gonna call it self-play, and it's not a test in itself. Self-play. We're going to start off with a board that the user would give us, or that the test would start, and which side we want to be, which side we think is going next. We can figure that out, but I think it's easier just pass it in. Okay, so how would we do this? We want to keep track of the moves that we make. We're going to have an array, an empty array, and then you can say while. Let's see. We have a board already. So while what did we have? We want to continue until there are no more moves to be made. So either somebody's won, or which we have a function for to tell someone's won, and if that returns non-zero if somebody has won, or we have is full, which means that there is no more moves to be made on the board. So let's see. So while it's not true that the board is full, and it's not true that anyone has won. Actually, has won is not equals 0. Okay. So as long as nobody's won and the board is not 0, then there are moves to be made. So let's say we're going to go find best move. We just want to make a series of games until we're done. We're done trying all the moves to play out a full game with the computer playing itself. So there's going to be the current side. So we're going to pass in the board and the side, and now we want to record the moves. The result is basically a move. So if I say moves.push, This find best move returns a move to us. So we want to update the board now. Well, actually, we'll record the move that was made. So we'll push that onto the array. So what that does in a push, you can go show an example. Where's my browser window here? Oh, I need to shrink this guy down so you can see it. So say we have an array 1, 2, 3. And if I say array.push of 4, now our array now has 4 things in it. So it keeps adding to it. And if I start off with an empty array, so if I have an array is empty, a.push 1, a.push a 2, and I look at the array, it has a 1 and a 2 in it. Okay, so push just adds to the end of the list, and it's kind of like a data structure called a stack. And so the labels push and pop are used. So a.pop would take that thing off the array, and it would remove it as the last element. So you could push things on and then pop them off in the reverse order. So the last thing you put in would be the first thing to come out. Anyway, but we're just going to push the results, push the move, which is, remember, is that object that has a position and a side. Put that onto our moves list. And now we need to update the board to actually make that move. So the result.pos is the position, and then the yeah, actually our current side is just the side. So that one, yeah, we don't actually have to use the result out of the moves list. And yeah, we're just going to keep doing that until the board's done, and so it's either a draw or somebody's won. And then this function will return the moves list, so it's going to return that array back to a caller. So let's try out that. We can run that function ourselves. That'd be kind of fun. See if that works. So self-play. And start with an empty board. 0, 0, 0, 0, 0, 0, 0, 0, 0, with X going first. Does it have any moves? Nope. So let's see why not. All right, try running this again. So we can step through here and oh, what? It thought that somebody had won already on this board. Is that really true? Or that has one function would be wrong then. Let's try that again. Oh, I'm still in the debugger. There we go. Let's try it again. Self-play. Okay, we're going to step into the has one function. Oh, I stepped over it. Oh, I made a mistake. Okay, try it again. Step over the is full function. Step into the has one function. And here we have an empty board. And oh, wait. Maybe did I just have the test wrong? Has one. Oh, yeah. As long as somebody has one is equal to 0. My test was wrong again. Again, I got that the errors are in my tests and not in the code so far. Okay, so as long as the board is full and nobody has one. So I had it before somebody had one. We're going to continue in the loop. Yeah, as soon as somebody wins, we're gonna back out of that. Okay. I think that's right now. Let's try that. Okay, we're going to continue this. Let's just continue, see what our result is. So we're calling it many times. Oops, stop! I have no idea where I'm at right now. I just went to a weird place. Okay. We said we got 4 different moves, which is really odd that we get exactly 4 moves. So I think that's showing a bug right there. Showing X going in the middle, O going in the left corner. Oh wait, and then also the side is always, oh, because it's the side here is not who's moving, but who it thinks has won so far. X is going to go in the middle, O is going to go in the corner, X is going to go in the top center thing, and then O is going to go in the right corner, and that's the end of the game? That's weird. That seems very weird. And there are no more moves to be made because the has one function, I guess, is returning. So this is a short enough sequence. I think we can actually just debug this. Let's take a look. Okay, so we know it moves 1. So we have the first result moving to the center. And then the next one, we're going to move to the left corner. And remember, oh, oops. The reason we won is because we're putting all X's into the board. I messed up the test function again. After we move, we have to change sides. There we go. How's that? So we're changing sides after every move. So we start off with X equals 1. And then we have O equals -1, and X is 1, and then -1 and 1 and -1, etc., as we move. So again, my test function was wrong. Let's stop this. Try it again. See what happens. We got more answers this time. We got a few more moves. It's very odd here. I think find best move returns. Let's see. I probably didn't document what side means. Find best move. Yeah, side means which side will win. It looks like here because we're recording that and we're saying which side is the winning side. Okay, so our moves here would be center, left corner, right corner, oh, I'm sorry, no, center top, and then right corner, and then center bottom, and then it stops. I have to draw it out. What is this telling us? Okay. So it's X is here. That's the first move. Y goes here. It's the second move. Then it says X goes here as the third move. Now it's doing O here. Well, that's wrong. And then it does X here. And we're done. Okay. So, as far as like finding a bug, this move is going to be wrong. So let's set up this as our initial board position for a test. And we'll see why we're allowing why O isn't going into the correct blocking position. let's just add it to, since we have a test that tests our boards like that, we can go add it down there. Here we go. So let's add a failing test. And this is a pattern that software development will take very typically when you're writing something that might be complicated, or you go back and forth between writing code and writing tests. And you might think like, oh, well, you just write the code and then you write all the tests and then you run the tests and they either find bugs or they don't. But in practice, there's actually a little bit more ping-ponging back and forth, as you see I'm doing here. At least that's how I work. What you typically do is write a simple version of some code. Oh, actually, no. A lot of times developers will write a failing test. That's the very first step. Like, to prove that your code doesn't do what you wanted to do, you actually start out by writing a test that you know is going to fail. And so you write some simple tests, things that you can think of about the way your code would work, and then you run, and your code could actually be like almost like just dummy functions, things that don't do anything at all, or just return the most basic, constant answer or something. You run your tests and now you have like a failing test. So that's a very concrete thing for you to do now as a developer: fix the failing test. And then you change your code so that it just fixes those tests, and you just do the bare minimum you need to fix the failing test. And then when all your tests pass, your next job is to write another failing test. So like if you have more general cases or other things, and you just keep going back and forth like that, writing failing tests and then making them pass by fixing the code, going back and writing more failing tests, fix the code until they pass, until eventually you can't think of any tests that would fail anymore. You've tried all the kind of most general examples you can think of, and then you're done. Like, your code is you have a whole body of tests that you will display, will prove that your code works for a category of tests, and then you can check in your code and go on, do the next task, do the next thing you're working on. And then every time you run all of your test cases, you're constantly checking to make sure that you didn't break anything in the past, and that everything's still working. So this is called test-driven development, and that's kind of what we're doing here. So let's write the failing test. So here we have a board, which is, and I think it's complaining because I'm using a little bit weird non-standard spacing here. Let me just go and get, it likes to put the tabs in this order. Developers are very picky about their indentation and tabs, and your IDE is also kind of picky about how things, it's not quite as compact this way, but the IDE seems to be happier formatting everything like this. Okay, what was I'm looking at our example. We had an O, X, and blank, and then a blank, X, blank, and then blank, blank, blank. And the next person to move is O. So here's our first test where O is going to move. And what do we expect? Well, because 0, 1, 2, 3, 4, 5, 6, 7. Position had better be 7, and we expect it to be a tie game. So yeah, I think that's right. So I think this is the case we want, and it's complaining. What's complaining about here? What I do? Oh, I didn't say what that was. That's the side parameter. There we go. The side property. Okay, so that is a test which we think will fail. Let's prove it. It's not failing. Oops. Really? I thought we looked at that example and it was failing. Why is my test not failing? I expected it to fail. Let's see, we thought it was failing because we saw this self-play finishing up. So what we were claiming was going to happen in this test was that, we wanted to go, we had position 4, which is in the center, position 0, which was here, here. So 4, 0, 1, and then we expected 2 because our self-play function was returning 2 for this case. Wait, 4, 0, 1, 2. Yeah. 4, 0, 1, 2, and then 7. 4, 0, 1, 2. Yeah, that shouldn't be right. Well, maybe there's a problem with my test function again. Okay, I'm going to look at it for a second. So we have a function test self-play. We start the test. We go through, we copied the form of our different test cases. So here's our test case. We just copied from above, which has a mixture of X's and O's. X only has one move, which is 7, so we expect that single move. This is a very simple test that we're writing. I think this will pass, and then we can add some more complicated ones. We go through all our test cases. We call self-play on the board and the test case side that it's supposed to be on, and then we make sure that the result equals the test case expected result, which is an array of some number of moves. Sorry about not showing the screen while I was typing that whole thing. So let's go. Oh, now there's a problem because assert equal, the way we've written it, it just compares two things together, and arrays don't work that way. Let me show you an example of equality and arrays in JavaScript. Because they're kind of like bigger structures, the equality operator does not, let's say B equals Z. Let's make A and B both equal to the exact same type of array. If I can type. No, I can't type. So A is an array with a single element in it, and B is an array with a single one in it as well. But I say, is A equal B? It's because that's no, it's not. Or even that weak equal, that A double equal B? No, it's not. And it's because since arrays could be really big and everything, that JavaScript didn't make a thing that's called, it's kind of like, for array equality, if you want both arrays to be the same length and the same elements in that array, you actually have to do something that's called a deep equality. And JavaScript array equality, comparing arrays in JavaScript. So usually you do something like this, and there are different. You can write your own, and there's actually kind of a little bit of a trick for what there's a trick way of doing it. I don't think there's any like array equality in every. Is there an array deep equals? It's called deep equals in JavaScript. I'm just trying to remember if there's anything that's built in. A lot of libraries have stuff like that. No, here's like somebody's writing this long function to do it. But there's a little bit of a trick that, like, for our purposes, is actually okay. Notice that there is a, let's let's see, object to string a. No. A. What is it? Oh no, I know what it is. JSON stringify a. So JSON format is a way that you can encode any sort of JavaScript or the basic JavaScript objects like numbers, strings, and arrays and objects, and then any hierarchical version of that. So if I do JSON, if I do JSON stringify of a, you'll see that it gets it returns a string which looks like left open brace, one, right open brace. It looks like an array, and I can do that for both A and B. And if you notice, since they are the same, they have the same string values. So if I compare the stringify version of A with the stringified version of B, those equal true. So it's a little bit of a hack, but it actually, by converting both the values to strings, we can compare the strings, and if they have the same basic structure, they'll compare equal. So let's change our assert equal to convert these values into strings. So what I'm going to do here is I'm going to change the value to the JSON stringify value, and I'm going to convert the expected to the JSON stringify the expected. Now they're both strings, and I can put a little comment here. I'm going to say this is a hack. Convert values to JSON format and compare that to handle arrays and objects better. Now I say better because I think there might be, for arrays I think it's fine. For objects it might not work because the order of the properties isn't guaranteed to work. So let's note, let's see, might be wrong for objects. So I'll just put a little dot there. So, but it'll work for arrays, and let's see if that works for us now. So now we change assert equal. I do test. Oh, I don't think I added that function to, what was it, tests? Where's my new function? Test self-play. I don't think I added to my list of all the test in test all. Test self-play. Okay. So, but we can just try the test self-play function. It didn't work. Okay, great. We have a failing test. That's progress. So we either have a bad test or so I returned an empty list instead of what I expected to see, which was an array of one element. So let's just try setting a breakpoint here when we run this test, and run it again. We can step through and just see the test case. Make sure test case is the board with an array, and then we do self-play. Yeah, our result is an empty list. Okay, so let's do that one more time, and this time we'll step into the function self-play. Step into here, and okay, so we initialize our moves to empty. We go in here and it's not full. Oh, it says somebody's won. This is a case where it thinks that somebody has won already. Did I make a mistake with this board? Oh, wait a minute. This is a weird board. Which board am I doing? Oh, yeah. I did the wrong board. XO, XO, XO. Oh yeah, this game already has a winner. So there really is no, I chose a very weird, I chose a weird board where it actually has a winner already, because X has on the diagonal is already a winning position. So maybe some of my test cases have been flawed from the very beginning. Let's go back. I think what I was doing here was XO, 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 and then I was saying, what's the best move? Well, it's kind of a stupid question because X is already won. So I think we should say maybe fix that in the find best move to actually not return any move at all, or we say that find best move should never be called with a position like this. So you have to define whether is it legal to call find best move if there's already a winner. And actually if I look at find best move now, it should already be returning that somebody has won this board position. So what am I missing here? It should be returning a position of undefined, and oh, you know what? I tested to see if it's a losing position, but not if it's a winning, if it's already an already won position. So maybe we should fix that. So if has won is not equal 0, then return, we want to return which side won. That might be a better way of writing find best move. It's not the way we'd normally use it, but it's probably safer to write the code that way. So let's change this, not equal 0. And we'll make a comment here. Either we've already won, or our opponent has won. Either way, make no move. Okay. So, and the value we're going to return back is the value of who has won. So we ended up calling this function twice, but it's not a very expensive function. Has won is, it's going to loop through the board once, you know, because we're just testing it for 0 here, and then we're returning that value here. It's maybe slightly inefficient, but probably not anything worth worrying about. Okay, so our tests are now, I think that other test is going to fail. Let's see. What's going on? Whoa, so I typed the wrong file again. Test all. Oh, what's going on? Test all. There it is. Correct position failed. And so that is test number 1 of find best move, and which was down here. Find best move, because this is now, it's supposed to be undefined because X just won already. So let's try that, running a test again. There we go. Now we have test self-play, which is failing. Okay, on that same test, because it actually should be the empty. It's a test that's wrong, because on that board position, it is, that is right. Oh, let me turn off the breakpoint. Okay. All right, we're back to all non-failing tests, but we have a new test framework to add to test self-play. So let's go through and let's try the case. What were we doing before was I think it was this case here where we were surprised by how oh, I didn't show you the code again, did I? Sorry. So we're going to add a new test to test self-play, and I fixed this test here to be undefined instead of we had position 8 before, which was making a move. It could make a move, but it already won, so it's like it was kind of ridiculous. So that's a better result for that case, but we probably don't ever, call that in the normal workings. We would expect to call that function that way, but it's safer now. This is getting to be a pretty long video. I hope you're keeping up, or you're going to be falling asleep. You're probably going to watch this in a couple different sessions. What are we trying to do? Let's go back to what I'm thinking is, we had this case where self-play, oh, I had a different version of self-play. Self-play passed with an array. Oh yeah, this one. Yeah, that's what I was doing. That thing is returning a weird sequence. And that sequence was position 4, position 0, position 7. And here we're saying that we expect O to be played in this position in order not to lose. So let's go ahead and test for that. Okay, back in the code. We'll make that a test case for test self-play. Where it is? Where is it? Just test self-play right here. I'll go ahead and copy this thing, paste it there. We don't need this. So it's 0 in this position. It's a 0, blank, 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 x, blank, 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 x. So in this position, we certainly expect O to move. Okay, now we're just going to put the first position here. So we're going to add 2. It would be position 2. There might be more things after this, but for the purpose of our test, I think we can just write that, and then we'll fill in what the full game really should look like going forward from this game. And the nice thing about this is that our code will kind of inform us a little bit. We don't have to work it out manually what all the moves to expect. We just kind of confirm it instead of generating it ourselves. Test self-play. Okay, so now we got a, oh, I forgot. Self-play, oh yeah, it doesn't return a move. Like, oh, is that right? Self-play move list is not the same thing. Let me see. Self-play has a more complicated move list. Oh yeah, let's not push all of the results. Let's just push the position instead. I think that would be better. There we go. Okay. So now we have a move list that's not the same. So we were expecting the first move would be a 2, and instead it's what we saw before. Oh, wait a minute. Maybe we like this move list. I don't know. Oh, this isn't the same game that we saw before. We expect it to be, it's saying actually move here to 3. Oh, but then X moves here. Well, that's weird. All right, something really weird's happening. So let's debug it. Let's go to self-play. That actually was not a terrible move. Yeah, right. So the O is not making the bad move. Maybe it's X that's making the bad move on that. So let's see what's happening. Or I could add it to the test case and just move further on. Oh well, it's that board position. That might be okay. Let's see what. So if 3 was the next position, we would expect X to go 6. So 3, 6 would be an expected result for that, and instead we got 3, 1. So that 1 is the first case where it's not matching up. So let's do a breakpoint here and run this self-play again. And yeah, sorry, let's make this a little smaller. Okay, so testing self-play, we are in it. Our test case is this array. Wait, oh no, this is the first case. We don't want that one. Let's continue on. Now we have, here's the case we want, where you start off with an O blank 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 X blank 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 X. Okay, so that's the case. Where should O go? And if I step over that, I'm getting the result, which is, oh, I'm sorry, not, oh, the result, which is the first move, which was in position 3, and then all the other positions after that. 3, 1 in particular. So we didn't like that. So we're gonna have to step into that function again. So let's call it again. That's the wrong call. Now the next one, this is the one we want. So we're gonna step into this self-play. Oh, I just did over. Oops, started going. Skip that one. Step into this one. Okay. So here we have self-play. Moves, start off with blank moves. Find the best move. I think the first move might be okay. Position 3. And it still says that X is going to win, though. That's weird. It thinks that X is going to win, even though the current side is... Oh, wait a minute. Oh, did I mess up the side again? Oh, it should be O to move first. I messed up the test. That's why I'm getting a different result. In the case where there's already 2 X's, the next side to move is O. Okay. Here's where I expect the. Well, I expect it to be 2, and I think O is answering with 1. Let's go back again. No, that's the wrong one. Where was this array? Let's see, I want this array. Oh, let's just set the breakpoint again. Test self-play, where is it? Test self-play. Skip this one. This is the one where I go into, step into the function. Wait, what did I just do? It's already failed. Stop. Okay. This is not the one we're testing. I'm going to go to the next case. Okay, here's the one we're doing. I'm going to step into self-play. Why didn't that step? Oh, because I stepped over. I'm sorry, sorry about that. Hitting the wrong button. Okay, just continue. Step into this one. Okay, so now self-play is moved the side. Load is the side variable. Make sure it's -1. Yes, it's -1 now. So now we step over this one. The board is not full. Nobody has one. Find best move. It's going to be, it says position 1, which I think is not right, because it's, yeah, that will lead to a bad outcome. So how do we find out what that is? So I think we're going to have to set a breakpoint here. So now we're starting to get deep down into what is actually wrong with this game. And I think the best way to do this is to actually, if we start debugging at the very top level, then we end up having to trace through all the other sub-levels, and so we're really trying to find the very first place where an error happens, because other errors can compound other errors, and so we really want to find kind of at the end of go to the very end of this game and figure out which move is the wrong one. So we had this list here saying when we start from this position, I think we said position was this one. That's our position, and O is to move first. Then we end up with a sequence of moves that, instead of beginning with O moving in the number 2 position here, let me show you that. Instead of O moving in this number 2 position, it is moving instead to this number 1 position. And let's just trace through the whole game here. So it's the number 1, then it's the number 2, then it's the number 6, then it's the number 3, then it's the number 5, and then it's the number 7. So there's several places where it was definitely obvious that X did not make the best move. So let's see, where was the first place where X was not making the best move? That was a good move right here when X moved there. So that's X number 3. But O moved to 6, and then, no, I'm sorry, I have it backwards. Let me go back again. This was the start. 1, 2. It's kind of forced to move there. And then 6. Oh, no, wait, this game is right. This game is right. I think I had X's and O's mixed up. Let me start over again. starting with this position. First move is O at number 1. Second move is X at number 2. Third move is O at number 6. Okay. But the next move is X at 3. So it's saying X to move at this third position, which is not, third position here, which is not right. Because X can win right here. So I think we have to say that the correct move for X is, well, even this position for O is weird because it didn't block this position for X. So it's hard to say like whether this O position really should have gone here or here. It doesn't matter, but certainly X needs to move. Not here, where it would allow O to block it, but it should be here. So 0, 1, 2, 3, 4, 5. It should be 5. So if I go back to this, we're going to expect if O moves to 2, so we're going to make kind of a deep case. I think 2 is an error, but it's hard to figure out what the error is at this point. So we expect it to be, oh, I'm sorry, didn't mean to. 1's an error, but for O, but which is the top centered one. So the sequence is 1, 2, 6, and then instead of 3, we expect a 5. So let's go down to that. This one. Oh, wait a minute. Oh, we don't have a way of, oh, we actually have a more specific board that we can fill in. So I think we want to fill in the more specific board at this point. So maybe we should be using find best move. You know, now that we have this position and we kind of see like where things have gone wrong, we can use the find best move function to enter this position in. So this position is, I'm going to add to this test find best move because we have a failing test of, I think best move is returning, yeah, returning the wrong value here. So we can test out just that one particular value. All right, so the position is -1, -1, 1, the top row, and then 0, 1, 0, and then -1, 0, 1. That's the board, and which X, O, X, O, X, O. X is to move, so 1 is to move, and we expect X to win the position by moving to position 0, 1, 2, 3, 4, 5. 5, and it should win. So this is what I've written. This is the line. That's the board. I just read out. X to move, and we expect it to be a win for X. Okay, so that test, that is the test that I think we expect to see. Let's see if we have a failing test with that. And let's just run test find best move. It succeeds. Now I'm confused again. Okay, I think I just wasn't running the test properly, but anyway, now it is failing. I was confused why it wouldn't be failing. think I was running the old code. I hadn't refreshed the browser. Okay. So now we have a failing test that it is trying to, it's in that kind of more complicated, we're in this position, and we're saying, why is X not moving to position 5 and it's moving to position 3 instead? So let's go ahead and set a breakpoint, and we'll actually step through the code and see if we can figure out why that's happening. So we're going to do test find best move. Where's that? Here, it's right here. Here's where we actually bring up the test case, and we can do call test find best. Now we have a bunch of tests that are okay. So I think we have 1, 2, 3, 4. Wait, I'm sorry. 1, 2, 3, 4, 5. We have 5 tests here. The 5th is the one that's we want to break on. So it's 1, 2, 3, 4, 5. This is the one. Minus, minus 1. Minus, minus, plus 0. Yep, this one. And we expect it to be, where's the expected, oh, it's in the test case, expect to be 5, 1. And instead we're getting 3, 0. Okay. So let's move into find best move. What's it doing? So we have this board. We're going to try all the positions. The top 2 positions, the first 2 positions are already filled, or the first 3 positions are already filled. We'll go through those. And now it's position 3 is where it actually thinks it's going to get the best move. So let's see why that is. If it moves into position 3, if you look at this board, O should be able to get a win by moving to position 2. So let's confirm that that happens. So we're going to move. Oh, you know what? I think I figured out. Nope, no, that's right. Okay. So we're going to move to position 3. There we go. And you filled it in right there. And yeah. Now we're going to find the best move resulting from that, which is wrong. So O is moving only at, is not taking advantage of X's mistakes and is moving to the wrong position. So let's find out why that's happening, because that's the root cause of this error. So we back it up. We'll back it up to, anything else, we'd step through here. It might be just fine, but it's because O did not move to the correct place. So let's start over again. Here we go. We'll do the same thing again. We're going to have to skip through all the 5 other cases where you don't care about. I think this is it. I stepped to the right one. Yes. I'm going to step into this function. And we know all those. So we're going to have to step into find best move again when it gets there. Okay, so here we're trying position 3. And now let's step in again. Now we're going to see why is O not taking advantage of the win it has at position 2. Oh, because it doesn't have, the board is actually filled in already. What? I'm an idiot. Okay, I think I was just getting lost. So if X, we were here, and now we're trying out X in this position. And we're seeing that if we do that, O can get a draw, which is not the best possible move for X. So we see that result here that O, if X moves here, O will move here and get a draw. And we see that here. The result is that O is moving to position 5, and it's a draw. So right now, so we're going to record that, and that's maybe the best move we see so far. So let's go down here. We don't have a win, and best is undefined yet. So we're going to record this as the best possible move so far. Okay, so that's fine. Now we're going to go back to our board position of trying out position number 4, which is occupied by a square already, so that'll be nothing. Now we should try 5. Now here's where we should get a win. We're trying out, oops, erase that. Okay, we're trying out position 5 right here. So we should see that as a win. Let's see what happens. Go show you the debugger. Here we go down. Board position, yeah, that we can move here. So we're going to try moving there. And yeah, we have 1, 1, 1. That should be a win. And the best move for, oh, that's interesting. If we do that, we didn't notice that that was a win. We never tested to see that the find best move is returning that it thinks O won. And the reason it thinks O won is because if O moves, I mean if X moves here, O can move here and also win. But we haven't seen that we've already won. So part of the problem is that testing which yeah, we're missing this test to see that X already won when we called that find first move. So let's see what is find first move doing then? Why would it not see that right up? Because I thought we had, if has won, it's returning. Oh. No. Yeah, right. So if either side of it's 1, which it should do right away, it should return that. But it's not. It's not returning that somebody has won already. Why would that be the case? Has won. What's something wrong with our has won function? Let's see, where is it? Where's the has won function? It's one of the first things we wrote. Oh, it could be we have screwed up this thing. 0, 1, 2, 0, 2, 5, 7. Yeah, it's in there. 2, 5, 7. This is the one we'll win on. Okay, so I think we have to go back in the debugger and get to this point again of find best move. Okay. And one thing we could do, yeah, we'll just start over. And we have a breakpoint in our test of, yeah, testing find best move. the fifth one. 1, 2, oh, 2, 3, 4, 5. This one, step in. We now know, like yeah, I think you want to step to here. Okay, so now we're trying position 3 for X. And we're going to abandon that because we said that one was fine because they're oops, there it returned that it was going to be a tie if it did that, which you think is okay. Then the next time we go to find best move, it's trying position 5. Our best is already a tie. Ooh. Why is the best? Oh, we already have a best pause of 5. Oh, I think I messed up. I went too far again. Okay. Sometimes you just feel like you're hitting your head against the wall. Let's see. This is it. Step into this. Oh, I stepped over. Crap. Step into that. A breakpoint just before we call find best move again. Okay. Here in find best move, we're trying position 3. 0, 1, 2, 3. Yes, and we think that's going to be a tie. Step over it. Oh, step over it. What? Step over it. There we go. Oh, we might be deep down. Ooh. I set a breakpoint, but we're actually deep down into find best move multiple places. So I was in the wrong find best move. That's why I was getting messed up because I have a breakpoint set here. Okay, that was a debugging mistake on my part. Here it is where I think this is the return place where we're trying position 3 on X. So find best move has only been called once. And you can see the call stack here. We are not I was debugging a recursive call and getting confused about that. So now we're at the top level of find best move. We're trying position 3. We've just found that our opponent can get a tie. And now let's get back around to find best move again. Calling find best move again for position 5. This is where we had a mistake. So position 5 here should be returning that we already have a win. Right, we're moving at position 5. 0, 1, 2, 3, 5. Yeah, we have a win already. And find best move is not saying we already have a win. Why? Let's go into find best move. So this is the recursive call for this. Has one board. It should return of. Let's step into has one. It should be returning a 1. Step into there. Let's go through all the different ranks. There, the sum is -1. Oh? What? How to get a minus? Oh, -1. That's right. Yeah. Not the sum is. It doesn't matter. It has to be a 3 or a -3 or +3 to actually be a win. So it's not going to do that there. Here the sum is 2. Here the sum is 0. Sum is minus 2. 0. 2. Let's see. How do we... I think we just missed it. That last one that came back 2 should have been a 3. So we're testing 2, 5, and 7. 0, 1, 2, 5. Ah, it's supposed to be 2, 5, and 8. So it's a bug in this data set. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Those are correct. 0, 3, 6, 1, 4, 7, 2, 5, 8. That was a bug in the data of what is in the last row wasn't correctly set. So all of our calculations were testing for a kind of a weird kind of a 3 in a row, which was not really 3 in a row. We were testing for we were testing for this one, and this one being on as 3 in a row. Okay, and then the last one, 0, 4, 8. That's 0, 4, 8. Yes. And then 2, 2, 4, 6. That way. Okay, I think that data's right now. Okay, well that was a hard to find. So that was the bug, was that number was wrong. How do we fix that? Let's see if test best move. Add a breakpoint. It passes now. Okay. How about test self-play? Okay. Here we have a failing test. Let's see if it's still what we expect. Test self-play. This is this second one here. Oh, I'm sorry. Not showing it. So test self-play. This second test is the one that's failing. Instead of 1, 2, 6, 5, it's returning 2, 1, 7, 3, 6, 3, 5, 6. Maybe that's correct. Let's go take a look at what this test is really trying to do. So we are testing, the initial board position is O, up, X. It's this position here. And so O is to move first. And it's saying that it now wants to move here, 2. And X is going to move here, 1. Then O is going to move here, 7. This looks good. Then X is going to move 3. Yes. Then O is going to move 5. And X is going to move 6. And nobody's going to win. And that's the correct sequence, I think. So I think our test was just incorrect. I had it coded wrong. So let's fix the test. That looks like a perfectly reasonable sequence. We expect it to be 2, 1, 7, 3, 5, 6. Oh, 6. Let's try running the test again. Passes. Test all. They're all passing now. Okay. Let's try the self-play of an empty board again, and just see, now that we have fixed that problem, self-play of an empty board with X to move first, and look at the sequence that we get. And I'll go ahead and, so it's 0, 4, 1, 2, 6, yada, yada, yada. Let me see what that position represents. and see if we think that is the correct move to be making. Okay, it thinks x should go to 0, then O would answer 4. That looks good. X would go to 1. That doesn't look like the best possible move. Oh, well, maybe it is. X goes to 1. O goes to 2. X goes to 6. O goes to 3. Yep. X goes to 5. O goes to 7. Doesn't matter. X goes to 8. Yep, that looks normal. So I think that's a good sequence. So let's enshrine that in code so that we can confirm that we'll look, make sure that remains stable, and that when we test for that board position, that we would actually get that. So let's see. 1, 2, 3, 4, 5. Okay. X, and the move list we expect then is 0, 4, 1, 2, 6, 3, 5, 7, 8. Okay, and let's test that. Test all, and all of them are passing. All right, so I think we have a reasonable tic-tac-toe game here, with the exception that it doesn't try to win as fast as possible. So why don't I leave that for another day? The video's already gotten really enormous, and so to review, like we've gotten a function called find best move, which will find the best move for a given board configuration as far as we're able to test so far, and it uses recursion to do that, to search all possible moves. And then we have a series of tests that test not only that, but also kind of the helper functions and make sure that those are all right. And unfortunately, I would say what I should have done, instead of like fixing that rank array right away, a better practice would be to create a failing test that would show that was wrong. That when this was 257 and saying that then it would not detect certain 3s in a row, that indicated to us that we didn't have a test case for that. Let's see, and let's look at that. So our tests were not sufficient. Where did we test for? Test has 1. There it is. We had 2 tests exactly. We had the 0 diagonal, and we had no winner. And that was the sum of all the tests for test has 1. Had we had more tests for this function, we would have found the error earlier. So actually, before I leave, let's just go remedy that and remedy the fact that we had a pretty bad set of tests for test has 1. I think I just assumed it was going to work, and that's making assumptions like that is bad. So let's revert this code back to the way it was. And if we do test all now, we're going to have some failing tests. A bunch of things but they're not very. The root error isn't in any of these functions. It's in the test array, which we missed. So our punishment should be to go back and actually write better tests for test has 1. And let's do something similar to what we did before, where we have a list of tests, and so we can be a little bit more complete. So let's create a test cases here. We'll have an array of test cases, and the first test case is going to be the board. Is this board? We'll go ahead and put our tests that we already had here. And we need to name it. I think we'll just do that, and then we'll say we expect it to be -1, so that there is O has a win there on the diagonal. Then our next case is going to be this one. Sorry. So that's the board. And we expect nobody to win on that one. So first of all, let's just get this test cases working. For var I equals 0, I less than length of, I'm sorry, test cases dot length I plus plus. So I loop through all the test cases. The test case is test cases of I, and then we're going to have these have one assert equal that has one of test case dot board. Yeah, and that is equal to test case dot expect. And then we'll have a little string here that says what this is. This is test number I. I don't know what to put. I'll just say I. It's just gonna have a string which is the test number, so we'll know which one fails if it does fail, or when it will fail, because it's going to fail in a second here. Okay, so that's that. I have an error here. Where is the error? I got a bunch of errors. Oh, I didn't open an array here. There we go. And I have another error here. Oh, this is not a comma. This is a semicolon for a for loop. Okay. All right. Let's see. So test has one. They pass right now. Now let's write that failing test, the one that we're shamed into writing. Let's say it's X is on the third row, and I guess we could put two O's here. Let's put two O's in the top, and then an X there, and then 0, 0, X, and then 0, 0, X. That should be expect 1 in this case. And let's see what our test does. Oh my gosh, it failed. Okay, now that we have a failing test, we are justified in fixing the code. So instead of fixing something that doesn't have a failing test, write the failing test first, because then you have something that then confirms that your changes are correct, and you have kind of evidence that, like, the before you made your change, something was failing, and then after you made your change, something succeeded. So this video is ending up being like a little bit more of a showing how, like, debugging, debugging techniques, a lot of mistakes on my part, but that's the kind of thing that happens, and then you're not really sure where the code is going wrong. So anyway, so that is one test, but maybe we should, how would I test that function a little bit more carefully? Test that, you could test like each and every column and row, like, to see that they are, make sure that they are all working properly. So that would make sense, or it's a little bit of work, and it seems a little excessive just because there's so many, but given that we had a mistake like that, it wouldn't be bad to do that. So if instead of writing out test cases by hand, why don't we just write some code that generates all the cases where we expect them to detect that it has one is true. There's also tests for winning ranks. And we don't want to use we don't really want to use the ranks array that we had set up, because that's going to be kind of defining prophecy. So let's just do it kind of by hand. We're going to test all the rows. Then we'll test all columns. Then we'll test all test the 2 diagonals. So there are only 3 rows. And we'll create a new board with all zeros in it. And then we're going to, so for each of the rows, there's a formula for each of the 3. There's always like a sequence. Of what those cells are. So it's going to be board of I times 3 plus j equals 1. And after that board has been created, we can assert equal has 1 of board, it equals 1. And we can give the name of the test, which is just, we'll just put the board in there. So it would actually dump out it would print which board failed in the case that it fails. All right, so that's rows. I think we could probably use the same loop to test the columns too. We'll just leave it all in. Let's do rows and columns here. Come up with a formula for that. Oh, well, we need 2 things. Now I'll just make a copy of this loop. I did this in the wrong way. Oh, I didn't. No, each row. Right. For each row, we're going to create a new board. And then we fill in the 3 things that are there. And use a very similar array for test all columns. So when I say rows, I could say row I. And here I could say column I. So here we're going to do something kind of similar. It's going to be column. It would be, I think it's just the opposite of this. So it's going to be 0, 0, and then we're going to do the one that's 3 bigger, and then the one that's 3 bigger than that. Those are going to be 1s. 2, 2, 2. Yep, that looks right. And then we'll test the diagonal. And those ones we probably can just do manually. Or in fact, why don't we could do them up here where we have listing them out. So this is, I wrote all this code so I didn't have to write 6 different arrays up here. I'm not sure. I'm not sure which is better. It's kind of like more stuff I wrote here than these 6 tests I could have written, but I'll just put that here. The diagonals here. That's the one diagonal. And the other diagonal. Oh, I used the wrong character there. This is an array, not an object. That's the other diagonal. I'll just leave this as is. Test all rows, test all columns. Okay, test has 1. Okay, they all pass. 11 tests, does that make, we have 6 here, 7, 8, 9, 10, 11. Yep, that's passing 11 tests. Okay, we have done our penance and written our tests. We have all of our tests passing. And this is a good place to stop. I think there's a case where we might want to optimize for winning the fastest and figure out how to do that instead of taking any old win. But it's essentially correct now. It should play correct tic-tac-toe. In the next video, I will hook this up to a web page, and so you can actually play against the computer instead of just running tests against the function that plays itself. Okay, bye.